Assalamualaikum and very good morning, everyone. My name is Amri bin Yusuf. Today I and my group will present about fluid mechanic group projects, which is the topic is offshore wind turbine. Next. So my group members is first Muhammad Daniel bin Marzuki. The second is Atal Arif Muhammad Shah bin Saili Joko Setiano. Next, Ahmad Hakimi bin Hashri, and myself is Ahmed Amri bin Mak Yusof, and the last one is Isma Haikal Hakimi bin Omar.
Okay, for introduction, offshore wind energy is the clean and renewable energy obtained by taking advantage of the force of the wind that is produced on the high seas, where it reaches a higher and more constant speed than on land due to the absence of barriers. Installed in the shallow waters, which is up to 60-meter deep, and away from the coast, marine traffic routes, strategic naval installation, and space of ecological interest. Next. The advantage of this offshore wind turbine is that wind energy is renewable, unlimited, and non-polluting. More wind resources offshore than onshore, up to twice as much as in a medium onshore wind farm. Larger size of wind turbine can be installed with no limitation area, generate and supply more energy, does not use space on the ground. Next. The working process of the offshore wind turbine is that the first one is the force of the wind turns blade. The blades are attached to the nacelle through the hub. The low speed shaft spin at the same speed as the blades, which is 7 to 12 turns per minute. The gearbox increase the speed more than 100 times and transfer it to the high speed shaft. The high speed shaft, which is 1500 revolutions per minute, transmit this speed to the generator. The generator transforms the kinetic energy it receives into electricity. Next. The electricity produced by the generator is fed down through the inside of the tower. The converter converts the direct current into alternating current. The transformer raises the voltage from 33 kilovolt to 66 kilovolt in order to transport it across the wind farm. The electricity is transmitted via underwater cable to the substation. At the substation, the electricity is converted to high voltage current that is 150 kilovolt. Electricity is transported through the distribution networks until homes.
Good morning, everyone. So today I will explain about the fluid power technology and the application. Okay, the overview. Wind turbine are used in a variety of applications, from harnessing offshore wind resources to generating electricity. Large wind turbines are often utilized by utilities to supply power to the grid. Wind farm can include a handful or hundreds of turbines with enough electricity to power tens of thousands of houses. Wind turbines are often located near the power generator will be consumed, such as neat houses, telecommunication dishes, or water pumping facility. The technological resources potential of wind over US coastal seas is sufficient to generate more than 4,000 gigatons of energy. So one of the fluid power technology is hydraulic pump. The positive displacement pump. Investor of this pump is CTCBS. Is credited with inventing the hydraulic or positive displacement (PD) pump approximately 200 before centuries. The concept of the positive displacement describes the movement of fluid by confining a definite amount of it and then driving the confined volume out of the confining. Pumps are classified into two types, which is kinetic pump and the positive displacement pump. The primary distinction between these two broad groups is that kinetic pump are used in fluid transport system, while positive displacement pump drive system are used for fluid power system. Positive displacement pump account for just around 10% of all pump in use. A pump is a device that transfers mechanical power, torque rotation speed to the pressure volumetric flow rate. The kind to use it is determined mostly by the rotation speed and needed pressure. On occasion, the type of fluid is used. So kalau kita boleh tengok, back balik. So if we can see, this is the figure of pump, which is dia ada flow water suction. Dia akan melalui pump dan akan discharge. So daripada situ dia punya electricity akan terjana lah. Next. The next pump is radial piston pump. Radial piston pump ni, one of the company that focus on this pump is Bosch. Bosch drive system design has recently shifted to power transmission application in renewable energy technologies such as wind and tidal turbine. Radial pistons rotate along a cam ring, which is the key to their technology. A combination of minor tolerance and efficient sealing between piston and cylinder wall allow to great volumetric efficiency. Next. Okay, I will pass to the next presenter. Thank you.
One, will present conceptual design for offshore wind farm. Okay, first, design consideration. Economic. The energy price and pricing similar. Any power plant economic viability. Increase focus on power optimize, reducing the number of components, facilitating business access, and the advantages of higher tip speed ratio is okay. Second, computation space. The base site of an offshore wind farm must have a favorable wind climate, lie on shallow water, and placed near the grid connection point for export and producing power. Right? The third, water depth. So far, commercial offshore wind farm has been installed in relatively shallow water using fixed support structure. Deeper water require either a relatively large support structure or open structure. For 4, distance to the port and onshore grid. The cost of cabling and the option for power transmission are determined by distance to the shore. Next. Okay, design conceptual section. System must be safe, environmentally and easy to use, maintain, and dependable, robust, small, and energy efficient. For operating requirement, the mean wind speed at height between the cut in and cut out wind speed for a turbine power and production to be at its highest. Main component. First, positive displacement pump. Positive pump of with a repeated plus a fixed volume with the aid of sail pump moving infinitely to the system. Then hydraulic control. Proven with pressure to rotation, then and turbine. Transfer the from moving water to the shaft to the next last two. Michael.
Okay, for next slide is dynamic response analysis. Dynamic response analysis ni is a technique used to study how a structure or system respond to dynamic loads, such as wind, wave, earthquake, or the motion of machinery. This analysis involves assessing the load on individual components, the structural response, such as displacement, velocity, and acceleration. This analysis is the main objective is to predict how a structure or system will behave under various circumstances and to pinpoint the potential failure modes. This analysis also can be used to improve the structure or system overall performance, guarantee safety, and optimize the design. Next, this analysis is used to determine whether the turbine can withstand the load it will encounter while operating and to spot any potential weak spot. For the technique, FEA and OCFD numerical simulation tools are used to provide a safe and dependable source of renewable energy. This can result in the shaft and bearing in the drivetrain bending and twisting, which increase component wear and fatigue. Next is passive torque control. The main objective of this passive torque control is controlling the torque applied to the turbine rotor by adjusting the current supplied to the generator. The rotor of the turbine is kept within a safe operating range, avoiding overstress or potential damage. This technique is combined with other control technique like active yaw control and pitch control to maximize the power output. The specific control include angular acceleration of the rotor is determined by the balance between rotor torque and the drivetrain torque, and the mass moment of inertia of the rotor pump assembly. If the rotor is operating at a steady state with constant rotation speed at constant with spin, omega sama equals to 0, torque rotor equals to torque pump. The combination of these different control strategies is used to regulate an offshore wind turbine rotor and drivetrains, the drivetrain response. Next, for discussion and conclusion, I will pass to Amri.
So for the discussion, we can say that from our research about this topic, which is offshore wind turbine. So we can discover that hydrostatic power transmission is beneficial for wind turbines due to the relatively low stiffness of the drivetrain. The most unusual of these configurations is a hydraulic wind farm, also known as Delft offshore turbine, which is DOT concept. The use of seawater as a power transmission medium for multiple turbines is a novel aspect of this concept. So the conclusion is the design as presented will significantly reduce the complexity of offshore wind energy technology. It is possible to build a prototype with up to 1 megawatt of nominal power output using commercially available of the shaft components. Pumps suitable for direct coupling to multiple megawatt wind turbine rotors are not yet available. So that's all from our group, which is we discover the topic of offshore wind turbine. That's all. Thank you.